Suppose that we have the graph of an inequality. Something that looks like this. This graph shows all of the numbers between -1 and 2. -1 not included, but 2 included. So this is the graph of the inequality. -1 is less than x is less than or equal to 2. In fact, this graph shows what's called the solution set of this inequality. It shows the set of all the numbers x such that -1 is less than x is less than or equal to 2. This is a kind of set that comes up very frequently. It comes up so frequently that we have a shorthand way of writing it. So what do these look like? On the number line, they're dots and filled in parts with no gaps. In set builder notation, we have just x for our expression and an inequality for the rule. And when we're trying to describe a set like this, we can use what's called interval notation. Okay, what is this interval notation thing? Interval notation is a summary picture of the graph, right? So what do I mean? The leftmost point that's shaded in is -1. The rightmost point that's shaded in is 2. I write a comma between them just so I can tell that they're two separate numbers. Then -1 is not included. I indicate that by drawing a round bracket, a parenthesis. The right endpoint is included. So I write a square bracket. So the round bracket is like the empty dot. The square bracket is like the filled dot. In the picture, I see that -1 is the leftmost point and +2 is the rightmost point. So I write -1 on the left and +2 on the right. So the questions that we go through are, first, we say what's the leftmost point? What's the smallest number in our graph? Is it included? Right, so did it come from a less than or equal to or a greater than or equal to? Does it have a filled dot on the graph? If so, then it gets a square bracket. Or is that point not included? Did it come from a less than or a greater than? Is it represented by an empty dot on our number line? If that's the case, it gets a round bracket. Same with the rightmost point. What is it? And then, is it included or not included? Okay, wait a minute though. Didn't an awful lot of inequalities look something like this? This is the graph of, I think, x is less than -1. And you'll notice it goes all the way off to the left. What do we do in this case? There is no leftmost point. If there is no leftmost point, we write round bracket -infinity at the beginning of our interval. So in this case we'll say round bracket -infinity, comma, what's the rightmost point? It's -1. Is it included? No, that's an empty dot, so it gets a round bracket. Note, this symbol always gets a round bracket because this thing, negative infinity, it is not a real number. It cannot belong to any interval because it's not the kind of thing that belongs to intervals. Okay, so that's what we do if there's no left endpoint. What if we have something like this, which looks like it's the graph of x is greater than or equal to negative 2? Right? Again, no endpoint here, but now it's no right endpoint. If there's no rightmost point, we just write infinity round bracket. So in this case, what's the leftmost point? It's negative 2. Is it included? Yes, it gets a square bracket. Then we'll put a comma, infinity round bracket. Again, just like negative infinity, infinity always gets a round bracket because this symbol also is not a real number. Okay. There is one extreme case. What if we have a number line that looks like this? That is, what if we have a number line where the whole thing is colored in? Well, that's kind of boring from a number line standpoint. We can still write the interval notation. Right? There's no left endpoint, so we say round bracket negative infinity. There's no right endpoint, so we say infinity round bracket. Right? We can write that interval. But this is just the whole number line colored in. This is just all real numbers, which we already have a shorthand way of writing. It's that funny looking capital R.